All right. Hello. I'm starting the stream. So, welcome. My name is Eric Normand. This is my office hours. I'm trying out this new thing. I want to talk to more people, help more people. So, that's what I'm doing. So, let me invite in our first guest, Jesus. Hello, do you hear me? Can you hear me?
Now I hear you.
Yes, I hear you too. Great.
Yeah, good. Hey, hello. Thank you very much.
Yeah. So I'm curious. What is your question?
Yeah, sure. So, uh, it's about your experience in the professional world.
Okay.
I wonder first if you do you do eh, private consultancy?
That's a good question. It's hard to answer. I am trying to do private consultancy. Yeah. So I've done it before. I'm currently not in any engagement. Yeah.
Yeah. So I wanted to learn about your experience there. The
Mm-hmm.
reason is I'm thinking on that, right? I'm thinking of uh, beginning to give consultancy. And yes, I really admire you, right? So I thought this was a great opportunity to get some feedback from somebody who do or not, or as you say, you have your own context. But the other side, I know if it's not consultancy, you manage your own businesses anyway,
Right.
right?
Mm-hmm.
So you have problems of accounting, documenting, legal domains.
That's right.
Uh, so there was yeah. So I was wondering, why can't you share about your experience in that domain?
Wow.
not
Yeah.
not yeah.
So the first thing in consulting, especially in software engineering, is we'll use the word consulting when what we really mean is contracting,
Yeah.
right? So we're just another programmer or engineer on the team, and uh, just getting paid hourly instead of a as an employee as a salary. So it could be that's what you want, but you could also mean something else about consulting in the more in the way that it's usually spoken about in other industries, where you are more giving advice. Someone is consulting with you, right? And so you're not doing the work. You are um, doing something higher level thinking than the work. So either telling someone how to do the work, or maybe you're doing um, the coaching or something like that, just giving advice, right? So I don't know which one that you're interested in doing.
I think that as many things in life, that is not up to me, right?
Well,
Yeah, like most of the time, what I'm aiming to is to be independently
I see.
uh, working, right?
Right.
Being able to choose, right, what to do and what not to do,
Uh huh.
and
I see. So you're
in
looking for freedom.
yes, that's right.
I see. And would you? And so when you want freedom, is it because you want the freedom to choose how you spend your time or how much time you spend, or is it a freedom? Because there's another freedom that comes with being independent, which is to not have a ceiling on your income, right? So if you're working at a job, they're going to have some pay range that you can get, right?
Yes.
And so there's just some maximum amount that they are willing to spend on you.
Yes.
Whereas if you're doing consulting, especially the second kind that I talked about, where it's more advice, you can often find um, that the problems that you're able to solve are um, valuable enough to the client that you can charge more than you would have made at a job, right? Um, the trade off though is that it's not as regular.
Mm. Yeah.
There's no agreement that you're going to get paid every year no matter what. It's simply it's on you to find the work.
Yeah, and that's maybe probably what I meant when I say is that part is not up to me. Is up to look, lucky, right?
Right.
A chance is what I meant.
Right.
Most of the time, I but I'm aiming to. I would love to work in that kind of second kind of consulting
Yeah.
because I understand. Well, I imagine that that can give me the other kind of freedom that I'm aiming to is the creative one, right?
Mm,
Where I can design more and
I see.
or at least suggest you are you're at least owner of what you are advising, right? You're
Right.
advising an idea, so you build your idea, design. It's up to the client, I suppose, follow it or not.
Right.
Whether the other kind, I imagine that is similar to what most normal uh, uh, work is, where you have some freedom of what you can do in your small scope, but most of the time you are directed about high level
Mm-hmm.
designs or depending of your position, of course. Uh,
So
yeah, but
what is your background? I'm curious, like what skills you have, your experience. What do you have to sell?
well, I have many years as a software developer, no? But I think one of the details about me is that I was uh, a professor back in my country. I'm from Venezuela, and I teach there in my university. And I really love that part. Right? I really enjoy that part. And everywhere where I work with colleagues, I've been recognized as somebody that can dispel problems
Nice. Okay.
with
That's great.
people, right?
That's a great skill.
Explaining, go to the point, try to guide, especially junior people,
Mm-hmm.
guidance, right? Guidance, like see it from here, see it from there.
Right.
Like, the typical professor student Socratic way. They try to find, I know where is it. I want you to find it. And I understand, I have a feeling my colleagues had shown me that they appreciate that. So I think that would be the detail about me. But beside that, software developer for years. I learned about you because I learned about closure,
Okay.
right? When I was in a research for something different, like every closure history is the same one, right?
Mm.
you, at least in this common denominator that we were trying to find there must be a better way. That's the common denominator. Everybody, we all agree that in one moment in our life, we feel there must be a better way. And there was this branch of options, and by chance, it was closure,
Yeah.
right? By
Yeah.
a coin toss. In my case, was a friend that told me, don't go there, go there.
I see.
And
Yeah.
yeah, and I feel like that's common denominator for everybody here.
Uh-huh.
But yeah, so anyway, but I think I share that uh, mindset of uh, caring about design,
Right.
caring about trying to do excellence, excellency, right?
Right. Okay.
Excelling on and I understand, or I try to study and understand the problems, the complexity problem.
Mm-hmm.
Thanks to, you must know that the out of dark pit was like the
Sure.
trigger
Yeah. Yeah. Yeah.
of
Yeah.
that thing. So uh, yeah, so I'm with this mindset in a world where I'm just trying to feed my family at the same time, right?
Right.
I'm just uh, doing my best job I can
Mm-hmm.
where I am. But I think I can find a space for my mindset in my independent in
Right.
business, right?
Right. Yeah. I mean, one of the things that we talked about freedom before. Um, for me, I I felt like at any company I worked for as an employee, I wasn't in a position to use my best skills, right? Like I'll give an example. I was interviewing for a job, and they had this problem that they wanted me to solve, as you often do, and they wanted me to work through it, and it was like a pizza place was having trouble keeping track of the pizzas, and things were getting delivered to the wrong address, things like that. And so I asked what I thought was like the most relevant questions, which was like, how many pizzas are you selling every night? How many employees do you have? Because then I could tell that they were making up the numbers on the spot. They didn't have it as part of the scenario. And they said
Yeah.
something like 20 pizzas in a night. And so I did a calculation like, okay, it's $20 a pizza times 20, that's $400. Like, you probably, if you're only making $400 in a night, like, you probably can't afford software to do this, right? And like, if it's only 20 pizzas, just go into the kitchen and look and see what is happening. Like, you don't need
It's,
software to tell you this. It's only 20 pizzas. You could keep track on a piece of paper. Like, if your team of like
that's
four
correct.
employees can't keep track of 20 pizzas, like,
It's a sense of scale, right?
yes, exactly. Like, you're not at the scale of software right now.
Yeah.
And
But nevertheless, that's a good exercise in all scales. Like
right,
imagine you don't have software. How is the process?
right,
How is it?
right. And so the I told them this, and they were like, "Oh, but then you won't do the exercise, which is to test if you can build a SQL table, right, to track pizzas." And I was like, "Yeah, but like that's my skill. Like if you want this was for a senior engineer. If you want a senior engineer, you want someone to tell you not to write software, right? Like you
Exactly.
want someone to like not
Exactly.
waste your time and the rest of the team's time like designing some piece of software that is not worthwhile. And I guess I found
Yeah.
that very often. That's just one example where, like, as a software engineer, you're kind of just told, do this, a new task, new task. And this, like, bigger thinking or thinking maybe more in a business way, and really trying to understand the problem so that you can solve it in the best way, not necessarily with software. Like that that is what I felt was limiting me. That's the freedom I wanted, was to be able to talk to the CTO, and say, look, this doesn't make sense. And then
Yeah.
the problem is you're not let into the conversations because you're just an engineer, like you're not.
Yeah.
And anyway,
Yes, I feel you. That's exactly the only difference in my case. So it's a communication problem or
mm-hmm,
or permission to talk with with important people. In my case, it's not it's backward. In my case, it's all I can speak is with my CTO, but I cannot speak with the users
Right.
or
Right. Exactly.
and try to and if I try to dig more into more information could be understood as not trusting my CTO
I
vision.
see. Hmm.
Uh, and so I never do it, right? But I feel like that,
Yeah.
uh, and and that's a cap in freedom if you think about that. But I know, yeah, I know that. So when you design by yourself, since you don't have that problem, you go directly to what you
Right.
think you need to
There's this.
to to dig the information you need to dig. You have it, you can find it available in any other circumstance. But when you have this hierarchical structure, sometimes you
Yeah.
have to wait
That's right. That's right.
until you ask somebody that asks somebody that asks somebody that asks somebody, and then you get some feedback eventually.
Uh huh.
Uh,
There's this essay that I'm gonna try to find. Um, it's about. I think it was written by Clay Shirky. Um, he was famous for a minute because of the book he wrote when social media was getting popular. But he um, he was talking about how he was paid as a consultant to come in to a company and basically give a report on like why something was happening too slow, something like that.
yeah,
And paid by the board of executives at the top, like they were they wanted to know why. And all he did was to go to the engineers and ask them, why are you working so slowly? And they had a huge list. They knew all the problems. And he delivered the report, got paid well for it, and he told them when he delivered it, you know, all I did was go and talk to to the people doing the work, and they told me everything, and it was very clear. And uh, the the executive that he told that to said, "Yeah, but I don't want to talk to them." Right? And so I
mm,
think that that is the
yeah,
kind of freedom, like that's what you're talking about with the
yeah,
hierarchy. Like people at the top, they kind of don't want to talk to the people at the bottom,
yeah.
and
Okay,
and
okay.
they would rather spend a big chunk of money to have someone else go down there, talk, and then report back because they're not getting the information from the chain of command. Like the
Yeah,
managers aren't pushing the information up, which I've seen many times at companies. Information doesn't flow up; it only flows down, um, and the they don't want to go down themselves, so they
yeah. I
pay
saw
someone,
it.
and they'll pay
Yeah,
someone $200,000 to do it. You know,
yeah.
and you have to do a good job. You have to write it up well and summarize and stuff.
Yeah, yeah. I suppose. So I understand that the hierarchy makes sense when you have to organize a lot of people. I mean, there's no way you cannot ar- have an architecture
Mm-hmm.
with a hierarchy when you organize a lot of people. The problem is when if that communication doesn't happen, it's it's it's, uh, it's it's really bad that it doesn't happen when what you are communicating is part of design decisions, right?
Yeah.
I don't care if I'm not see my boss any day, but don't be you the design decision that who make the design decisions.
Mm-hmm.
I suppose maybe let the team design or something like that, right?
Mm-hmm.
Uh,
Yeah, and okay, so some more advice while we're here. Um, most of the consulting work that people get, this is what I've read, and it's certainly true in my case, has been through people I know. I've only gotten jobs because I knew somebody. So I would work your
yeah,
network, You know, if you know someone working at a company, you need to have informal conversations with them, right? Understand what's happening at their company, what they need to, um, what they're struggling with, and need help accomplishing, because getting started in it is the hardest part. Like you want to aim for a very large fraction of your clients to be repeat clients, and if you have zero clients right now, like
Mm,
you have to like bootstrap this and
yes, yes.
get referrals and get into the position where people are thinking about you when they're having these troubles, right? And so that means getting very creative with who you talk to, how you ask, and what you offer them. You're just gonna have to. It's just gonna be brute force work of just
Mm.
figuring out. And you can call the same people again. You can propose someone something and they say no, and then, you know, 2 weeks later you call them again, like, I have a different idea. What if I did this for you? You know.
But you mean you're suggesting me to be proactive also in the sense that offer ideas or projects or something instead of waiting for the an open space where somebody needs something and is formally requesting, like request for proposals, for example.
Right. I wouldn't do that. I would go with people you know. So, you know, you said you had students, um, because you're a teacher. Maybe you go through your former students who are now in industry.
Yeah,
Maybe they, you know, can talk to their
that's a good idea, by the
supervisors,
way. Yeah.
etc., and get into companies that way. You probably have other, um, more like peers, right, from when you were in school and all that. Just contact them and just start conversations. There's going to be a lot of listening to hear what problems people are having. And so, I mean, like, just to make the process like a little bit more concrete, one thing I've heard, haven't done this myself, but it sounds like a good idea, is you have a conversation with someone and they're like, oh, yeah, we're having this problem, you know, getting our software engineering team to work, to be aligned on our vision, you know. And you talk to them, you like uncover it, you try to understand it. And then when you go home, you write up a proposal and you
Hmm.
say how much it's worth. And this is what you're doing when you're listening. You're trying to understand how much is this costing them? How many employees do they have that aren't working in a vision? Do they think that they can, you know, let's say they have 10 employees and they're spending $1 million on them every year. Uh, and if they were more aligned, they would generate profits of 2 million, but right now they're only generating 1.2 million, so they're like kind of barely paying for themselves. That difference now is where you're going to play. And if you
Hmm.
can get them up to 2 million, the profits, then you can take 10% of that, right? And so you propose, this is what I
Okay.
think we can get to, and how, because this is, I'm speaking abstractly. This, you have to uncover this while you're listening to them and
Yeah.
having conversation. And so you aim for 10%, and, um, propose how you're going to do it, and send them a written proposal, right? So that's the advice, is like every time you have a conversation and there's some problem that you think you could help with, just send them a proposal. Just get practice sending it in. Um, Maybe have a follow-up meeting where you ask for feedback on the proposal. If they don't accept it, like,
Okay.
why, what
Yeah,
was
that's
wrong
a
with
good
it,
one.
you know.
Yeah.
Keep the conversations going. um, yeah.
Well, this is great, man. This
All right,
is
Jesus.
awesome. Thank you very much.
Ya,
It
fue un
is.
gusto conocerte.
Igualmente,
Sí,
igualmente. Muchas gracias. Un gusto
esperamos
conocerte.
hablar otra vez y muy
Ah,
pronto.
sí, por favor.
Um, I thank you for coming on the stream, and I'll see you later. Good luck. Let me know how you do, and come back on office hours, and we'll keep talking. All right.
Okay, okay, for sure. Thank you very much. Appreciate
Thank
that.
you.
Bye.
Bye. Mateus. This is fun. That was a good question from Jesus. Okay, Mateus, can you hear me?
Yeah. Hi, Eric. Yeah,
Is
I
that
hear
your
you well.
is that how you pronounce it?
Mateusz, but you can call me Mati.
Mateusz. Mateusz.
Yeah,
Okay.
it's a Polish name, so out of szy, szy, czy,
Aha, yes.
all of those kind of things. So I wanted to connect because I'm watching the live stream right now,
Okay.
and your microphone is kind of low.
It's too low? Oh,
Yeah.
thank you so much for that. Let me see if I can adjust it up. Okay. I just put it about 50% higher. So that should be. Is that all
Okay.
you had to say?
Uh, uh,
Thank you for
that's
that.
why I called, but
Yeah.
while I'm here, maybe I can ask because I was watching lately your videos about doing the design and your new book, reading the chapters of your new book.
Mm-hmm.
And at our company, we are right now also trying to do domain-driven design,
Got it.
and we are using Clojure. And we are right now doing our diagrams about like entity relationships and value objects and all of that kind of stuff in Notion. In We are doing that in Mermaid graphs, and I was wondering if you have some opinion uh, on some tooling regarding the relationship diagrams or how you do it yourself when you are doing domain driven design.
Okay. Good, good question. A lot of things in there. Um, so I don't do domain-driven design. I have read the book, and I think that there is a lot of good ideas out there in the book. Um, um, I don't want to say anything ungenerous, but I find that when people say I do domain-driven design, the book is so big, and there's been so much like stuff from outside of the book, like there's a big community and there's
Okay.
conferences, that it becomes hard to know what they mean by I'm doing domain driven design. um, so you talk to two different teams and they think two different sets of things are important. So I kind of try to steer clear from that kind of thing. I feel like let me say something ungenerous. um, Often what happens is a thing gets branded, and the more ambiguous the thing is, the better for it to spread, because everybody can see something different in it, and everybody can you know claim to be part of the same movement community, even if they are not really agreeing on much, because they all think it's domain driven design, and it creates this like cottage industry of people like disambiguating it. So I don't. That's one of the reasons I don't say domain driven design when I'm talking about domain modeling. Um, so there's that. Um, when I
So
speak, yeah.
yeah, maybe if I can speak more precisely here, why we are doing the domain-driven design, and what I mean by that is more that we are trying together align on what is the core of our business,
Yeah,
what is the core
that's
of
great.
what we want to do,
Mm-hmm.
and we want what we also want to do is we want to also have this ubiquitous language. So of course we are mapping what we are speaking about as a business of uh, of our application to the same naming in the code
Yeah.
and the same concepts. and also like making it a little bit easier to exchange and on those and specify what are the concepts which are really about the business. And after that we also we are also trying to start also doing more design upfront, right? So try to think before we jump, to the code and trying to put more thought into what we will develop. So we can before we jump to implementation, we can already see where we need more flexibility in the code, where which things we can postpone more and stuff like that. So it's more about those values.
Yeah, and that's all good stuff. You asked about tooling. I've used, I like old school tools like pen and paper and whiteboarding. I find that they're so much faster because you need to iterate, right? You need to try it out and look at it, and most of it is just that. It's like evaluating 10 different ways of doing it. As for documenting it later, I don't know. I can't give a good okay, well, let me put it this way. My preferred way of doing it is in code.
Okay.
Like, I feel like programming languages are formal enough that they should be good for writing down a domain model. And the other advantage of that is that you can actually run it, right? And I think that in the domain-driven design book is one of the first chapters. He talks about part of the process that he would go through is he would go to the experts, he would get a whole bunch of ideas about like what they wanted. Then he'd go back and he'd code up some simple examples and like different ways of modeling it with classes and stuff. And then he'd go back to them and show them like, oh, is this what you meant? Right? And they'd say, oh yeah, but you forgot about this, and like, no, this doesn't really work the way we meant. And so then he'd go back and he'd work in the code again and come up with a new little prototype. And to me, that is the most valuable, that you can actually, it's easy to draw pictures and everyone's like, oh yeah, that's right. Yeah, the knee bone does connect to the thigh bone, but when you actually have code and it has to do something, that is like, that is the measure of it.
Okay, yeah. It's pretty much similar to what we do, because we also start first with some toy example, something to demonstrate what we will speak about, and then we then like to think about like what we find right now is that while doing that we have completely different thought process when it's on more on pen and paper, as you say, like more on the diagrams. There are some additional things that we would not think about when we go over the code. And it's I think it's giving also some ease to exchange on some more complicated topics, and or quickly going on something and explaining on already the diagram. But
can you give me an example? I'd love to hear more about this.
Yeah, so like an example of
something that's like something that someone was doing in code and it wasn't working right, or that someone was doing in paper and it wasn't working right, and they needed something more, or isn't that what you were saying? That like the
yeah. Let me think about it, because it's harder to think, like when you're on the stream, and it's a little bit additional pressure. So I'm looking at our diagrams right now and trying to think about something. Mm, mm, mm. So, uh, so for example, here, so we had a concept of because we are doing as right now software for logistics for supply chain, and we are doing our first module which is simulation, and we are a little bit in a deeper context because we are doing a library, and from that library we will assemble client applications or different libraries. And we had a case, for example, when we were planning the simulation engine. We have a concept of events, and those events are in a registry, which is tying event type to event execution. So then when the scheduler, which is basically iterating over like from which is doing iterations on and creating snapshots,
Okay.
which has another in each iteration is executing an event and then creating a new snapshot with some new state, new data on it, creating new future events and past events. And for example, we were speaking about we had this in code about and it was quite clear in the code how what is the event, what is the event, and how it interacts with the world. And then when we came back to diagrams and we were mapping that on the diagram, we found some we found problems with how that type is related to the event and how the registry is mapping that. But yeah, I don't think I'm clear with the example right now.
Yeah,
But
it's a lot.
yeah,
It's a part of a bigger model. I think the context
yeah,
is missing. Yeah, yeah.
yeah. So okay, so I will think about that, and maybe I can come back to you with an email
Sure. Yeah.
and
Please.
some example.
Yeah. One of the reasons I like code is when you draw boxes and arrows. Um, I guess it's not formal and specific enough to like so I look at the code and I can instantly see, oh, there's this corner case that we're gonna have to handle, right? And when it's just like a box with a couple arrows out of it, I don't see it. um, I have to either translate it mentally, like how would I implement that, or or just miss it, I guess. um, and the thing about code though is that you can get too specific, right? You can start implementing it too soon, and that's also a problem because you want to stay at a very high level, very, you know, box and arrows diagram level, like where you're still able to, you don't want to write code that you're gonna have to change as the model changes. You want to write just the model. So one thing I do is to write out examples, right? So here's this map, and it's gonna have these keys and these values, right? Um, Maybe I put some comments on there like this one is optional. Um, uh, this one has a range on it, like it's going to be an array or a vector, but it's going to have 10 items max, something like that. I'll put those kinds of things on it. um, but it's all code, and it's I don't know. It's just a step toward an actual implementation, but it's not the implementation itself. I also like
Mm-hmm.
using function signatures. Um, Function signatures as a way of clarifying a use case. Like, well, if you're doing diagrams like a UML use case, it's just so vague what's actually happening.
Mhm.
And I want to put like, these are the inputs, this is the data we need, and this is what it's going to generate. And that's what a function signature does. And you don't write the function yet. You just work with it at that level. And so I guess the
Seems
thing
like you would like Haskell.
I do like Haskell. Um,
Yes.
it's not. I don't like the type system isn't quite what I want. So um, I tend not to use it. It's a little too rigid. But sometimes that's what you want. You do want rigid, right? Um, but the type signature and in general, what you're looking for is something that is formal enough to make progress and be specific and precise about what you're saying without getting too bogged down in the implementation details. I don't want to decide now if I'm going to use a for loop or recursion to solve this. I just know that I need these two pieces of data and I need to return something of this type. And that's good enough to reason about because you could say, I don't think I could do it. I need this other third piece of data. And where am I going to get that from? Because it actually comes from over here. And so I need to pass that through. Like none of the entities in the middle are going to have that data. So I'm going to, you know what I'm saying? Like you see that,
Yeah.
you can see that in the code. Um, and I, I think the skill, and this is what I'm trying to do in my book, the skill is like finding that middle ground of it's code, it's formal enough, but it's not too implementation specific. Um, yeah,
Yeah, it makes sense.
yeah,
And yeah, definitely also about the signatures, it also I think gives you a feeling even like what data structures may be useful or where you may want to be more flexible. Like for
that's
example,
right.
okay, this part of the code may change, or we may want some different implementations. So maybe some
Right.
dev protocol here will be
Yeah,
useful. Yeah.
exactly. Like, yeah, this could obviously change. Yeah, I mean, I'm gonna have a chapter on volatility in my book. Um,
Yeah.
just being able to,
What? Yeah.
yeah, go ahead, go ahead.
Yeah. What I have problem with we while designing also is like finding a place where to really start and like to go minimal because when you have all of those different use cases in mind and all of those different complexities, it's sometimes hard to really find a good point to start minimal
Mm-hmm.
and because when you have too many concepts in mind, it's too entangled, it's really complicated, and
Yeah,
you're trying to do too many things at once.
yeah,
So
but at the same time, writing it out is shows you how complicated it is, and that maybe
yeah,
you need to start simplifying it. Um, like the writing it out is not making it complicated, right? A lot of people are afraid to write it out because um, it does show them. I mean, this happens to me, or I'm like, you know, I don't want to write down all my to-do list for the day because I know it's too long. It's too scary. I'm never gonna finish it. Um, but then you actually do, and you realize, yeah, that was good. It was good to get it out of my head, and then you can start working on it. You can start looking at different concepts and saying, "Oh, are these really different? Can we combine them?" And that makes it simpler. Often that reduces the number of operations that you have because you had two different things that were kind of the same. You can start seeing patterns in the type signatures, right? The function signatures.
yeah,
You can start to see like, oh, these are kind of the same. Um, they take the same types and they return the same type. Like they're probably at least of the same class of things. Um, yeah, all that
yeah.
is iteration.
Makes sense.
Yeah.
yeah. Also, it's nice when you do that in code. You also see the graph of dependency there requires. So it's also nice to see like what's your leaf and
Yeah.
and how complicated is the namespace really,
Right.
the concept,
So y'all are using
the place.
Clojure,
Yeah, yeah.
and it's
Clojure,
you
Clojure
said
script,
it's what was the domain again?
supply chain.
Supply chain.
Yeah,
Okay.
we are doing simulation now. And,
Oh,
yeah,
supply chain simulation.
yeah.
So like you could say
It's
like,
a
well,
lot about modeling also.
what happens if this factory closes and like now your supply chain doesn't run, or like you need to find a new factory to get that part from, that kind of thing?
Yeah, it's also like about creating a model and then running different scenarios in that model. And like for example, like you could check like what happens when you add a new machine, when you remove a machine, or yeah. Uh, it all depends also what's your objective to test, right? So
Yeah.
it's also interesting because the simulation is a lot about modeling. So you first need to create a model, and to create a model, you really need to know what is your objective, what you want to check. You need to get data, and you have also this process of going back and forward between model that you create and how it's done while validating that model. And
So you're
yeah,
modeling.
yeah,
Uh-huh.
pretty much.
That's fun. That's cool. No,
Yeah.
I actually this is just conversation now, but I actually had an idea. Never did anything with it, but it was to create software for factory managers to simulate their production line. Um, Never did anything with it, but I thought it would be cool if they could like put the workstations in their factory, and then um, see what happens if you move them around, and like how much time it takes to travel between each station, and if you put them closer,
Yeah,
can you?
that's exactly what it's about. Like this is what you can model
Oh,
here.
cool.
Yeah, there is some software on the market on that already, but a lot of the software right now is one thing is that they are using Java, and they have a lot of legacy code. So and the code is not so flexible, right?
Yeah.
Not to reuse between clients. So one problem is with that the software is really costly. And the second thing is also, especially for simulation, it's a lot about also how you implement it in the actual place where you go with that, right? So how you take data, how you make everyone work with that. You get the experts to also give you input on that process if something really makes sense. And yeah,
Yeah.
yeah. But even when I'm explaining it, I'm thinking already about like really domain driven design. When you get experts from the domain and you need to speak with them, they
Yeah.
validate your yeah.
Yeah.
So yeah,
Yeah.
it's
Do you have people on staff that are like were former factory managers who can tell you what they would like?
my co-founder is has spent 20 years in Michelin. Uh, yeah, he is from Chos, France, near Lyon, Vichy.
Oh, okay.
Yeah, and he actually worked a lot from the Michelin, like as a Michelin guy, working with different factories there
Yeah.
and doing simulations
Oh,
and
nice.
different, yeah, but also like a lot of stuff around Michelin and partners supply chain problems.
Right. Okay. That's cool.
Yeah, but yeah, that's all from me. Uh, Thank you very much for your time and for doing the live stream.
Yeah, yeah, of course. I want to do it weekly. I want to get I want to I don't know, more interaction with people out there.
Mhm.
Um and so thank you, Mateusz.
Yeah, so maybe I will think about an example of that going back and forth between diagrams and code and something that we find. Yeah.
Yeah,
For the
let me know
next.
how it goes. Let me know how it goes. I think it might also be a personal thing, personal preference. You know, some
Okay, so
people spend a lot of time developing UML. Like, they must like it. So, all right, take care. Thank you so much.
thank you. See ya.
So, I don't have anybody else in my participants list. If you are out there watching the stream, I hope my mic is better now. Let me write that in the chat. If my mic is better and you're hearing me, please join the Zoom. I put a link way up at the top of the chat. If you're there live and you have a question or anything you want to discuss. Okay, well, I'm just gonna go through the chat now. I haven't been really paying attention to it. Where are you at with your search for a grand unified understanding / theory of functional programming and such? Huh. Okay. Well, wait. This is building on a previous question. I'm going to come back to that. Faster Than Light Memes says, what is your current theory of why abstraction is powerful? I.e., why are general languages or stratified designs better than parochial designs? This is, like, very interestingly what I've been working on in my book, in the last chapter I've been writing. And I'll tell you what I think now. So there's really two aspects to it, and both relate to expressivity. The first aspect is that it's not that abstraction is powerful, it's that the proper abstraction that mirrors the job that you are trying to do. That is what's powerful. If it doesn't mirror what you're trying to do, it's useless, right? So you can't really say, like, oh, more abstract is better, this is more abstract. You can't even compare, like, how abstract something is. It doesn't make sense. It's not a relative term. What abstraction is you have some concrete domain, let's say factory working, right? And you want to represent that in some abstract domain. And so you create a mapping. Sorry, you can't see my other finger. This is the concrete domain, and you create a mapping to the abstract domain. And the quality of that mapping, that you can perform the same operations in the abstract domain as you can in the concrete domain, that is what gives you the power. Right? So if you find that you're working in something and you're saying, wow, this is really powerful, you'll probably be able to see that the power is only that you're able to express the ideas that you're having about the concrete domain in your abstract domain. It's not about, something being more powerful or less powerful. And so then to unpack that, the second part is that you need to be able to express all the things in your concrete domain. So not only do you have the operations, the individual use cases of what you can do in that concrete domain, that you can also do that in your abstract domain. There's also combinations of operations, which what I'm calling compositions, where the return value from one operation becomes the argument to another operation, and maybe it's not just two, it's multiple, and so those things then have to work in the same way as your concrete and your abstract level. So one example is something like, okay, let's take addition, just plus numbers, addition. That is an abstract level, and there's many concrete implementations of it. Let's say a pile of oranges. You have a pile of oranges, there's 10 oranges in the pile, and you can add it to a pile of 7 oranges, and you get 17 oranges, right? So you can model that with just integers. 10 plus 7 is 17. We're so good at doing addition because we've done it so much that this modeling and this mapping from concrete to abstract just seems so immediate, but it's not. I mean, that kind of hides how special that is, right? That we're able to do math and abstract away the oranges and the piles and the shape of the pile and all that stuff into this abstract domain that elides all those details and just says 10, the operation is plus, and then a 7, right? And that adds the two numbers together, and so you have these two piles instead of two piles added together. You get the same answer though, right? You get 17 oranges, or you get just the number 17 in the abstract domain. But plus has other properties to it. So if you take, let's say, 20 piles of oranges, you can express how you add them together. You can't you could just put them all together at once, right? You could do that. But you could also do it pairwise. So you take the 2 on the left and you put them together. You take the 2 on the right, you put them together. You take 2 in the middle and put them together. And you can group them and do the operation of merging the 2 piles together in any order. And when you finally have 2 big piles and you push those 2 last piles together, you're going to get the same answer. It didn't matter how you push them together in what order and how you paired them up and that kind of thing. At the end, as long as the oranges don't roll away, you'll have the same number of oranges. And this is reflected in the structure and the properties of plus. First of all, plus can nest, right? So you can have a plus b as a nested argument to, a plus b plus c, right? So you can nest, and this gives it an extra dimension of expressivity because the return value of plus is the same as its argument type. That's called the closure property, closure with an S. And that's what lets you create these rich, nested expressions. Okay, so there's the plus does the same operation as pushing 2 piles of oranges together, right? But it also has the same structure, and composing them works in the same way. So that's the 2 sides of why languages and like a DSL or stratified design works better than parochial design. You have to find the right abstractions. You have to find those right operations on those abstractions. And then you have to make sure that they have the right compositional structure. And the parochial design is much more like it's not looking for those abstractions. It's just trying to write an algorithm that will calculate the correct answer. And in doing that, it's missing out on the richness of the structure of the domain. And so it doesn't have the reuse possibilities, and it doesn't have anything surprising, right? You're not getting a better understanding of your domain. You don't get the added business advantage of having a good model. You've just built a for loop that adds up numbers. It's not taking advantage of the closure property, of the associative property of addition, the commutative property of addition. It gets the right answer, but you don't have something that you can use to solve the next problem. You're just going to start from scratch again. And so just to further talk about that, one more thing. So what you'll find is as the number of problems that you have grows, the number of problems that you're solving grows, so your code base is growing. If you do what you're calling a parochial design, it's going to just grow linearly. It can't grow faster than that. But if you're actually coming up with good abstractions, you will find that it grows like a tree. That you're finding, oh, this is a really useful, because it's layers, right? And each layer is calling lower layers. This is a really useful property, and I'll get to reuse it over here. Like, just like you get to reuse addition for all sorts of problems. It's not just adding two piles of oranges together, right? It could also be for adding two rocks together, or adding months together, or adding two time intervals together. Like, you can do it, plus it's just really useful. So you're finding these very useful things. And so the reuse comes because you can you don't have to write that for loop all every time. If you had to write a 10-line for loop for every problem you're solving, it's linear. It's 10x. Where x is the number of problems. But if you can find these points where you're getting leverage, then it'll grow logarithmically. That's my theory, at least. It's kind of hard to prove. It's just a lot of work to go through like a code base and be like, there's a high leverage thing. How much code is it saving? It's really hard to do. Okay, so this is the other question. LC says, where are you at with your search for a grand unified theory? Wait, so Emmanuel, you can join. Yeah, we have a few minutes left, so join the Zoom, and I'll answer your question. Otherwise, I'll go through with the questions in here. My grand unified theory of functional programming. I feel like I did my best I came up with the best theory I know for functional programming, and that's in my book. Maybe the presentation could be better. I do know, like, it's been a few years now since it was published, about 4 years, and I have been thinking, like, what I need to do is just take a copy of it and just like make marks all over and edit it, basically edit my own work and make the presentation better. But as far as the theory goes of functional programming, I think that's as good as I can do. I don't think there's anything more. If the domain modeling stuff is related to it, but it is more general. It's not specifically about functional programming. What is my take, also from LC, what is my take on the uptick in type theoretic approaches? Things like lean, for example. I don't know what lean is. Have your views on type systems changed over the years and since early day closure? Yeah, my take on type systems has changed over the years. I originally was very against type systems, but if you read my early writing, it was somewhat uninformed and incoherent. Like it just was this general sense of like looking for a way to explain why I don't like them. And every time I would talk about it, it would be kind of a different thing. And over the years, it has changed. One thing I've realized is a lot of what I didn't like was simply the rhetoric around it. So it wasn't type systems itself, it was the kind of argumentation that was going on both sides. And feeling like people were making unfair claims, and the claims that felt the most unfair were on the type theory side, because I don't know, I feel like they were um, overselling. Let me put it that way. Um, Type theoretic approaches. So, like, interestingly, I started learning Agda, and Agda has uh, a very big type system, and it's like it's dependent types, and you can do so much work in the type system for proving properties of your function, for instance. Um, so, like, you can prove that addition is associative in the type system, and that's you know that's cool. Like, I think that kind of stuff is super um, appealing when that's the level you want to be working at. Um, I am not good enough at it to. I'm not good enough at it to really see a lot of value yet from it, because it takes so much time, and um, often I'm not good enough at even the proof part. And it's not just writing out the syntax that I'm still having trouble with, but also the you know proving that addition is associative is maybe something I did back in college, but like it's been a long time, and I don't really think that way anymore. Um, Even though it's great that it is proven. So anyway, I kind of have put that on hold because I have other things that are stimulating me. Um, the uptick in type theoretic approaches, I think also Haskell kind of opened the door. This is more like industry wide thinking. Haskell opened the door for a strong type system to for people to appreciate what's there. Uh, so it like defines like this far left or right. I don't mean to associate it with political parties, but let's just say this far limit of what you could be doing in a certain class of languages, that kind of Hindley Milner style, because it has all sorts of extensions and higher kinded types and all sorts of stuff that may or may not be super applicable to what you're doing in a practical sense, but it's defining this limit of like, this is where it could go. And so by defining that limit, there's this huge design space that it opens up, and other languages have picked like very, like, I'm thinking about Elm, for instance. Elm is statically typed, Hindley Milner style, but it has chosen pragmatic points in that design space that limit, it's not as far, it doesn't open as much space, right? It doesn't have all the extensions, doesn't have higher kind of types, doesn't even have type classes, I don't think. And so it's found a space where this is actually for the domain that Elm is designed for. That type system is really well designed, and I think that there's a lot of room there in that kind of thinking of um, of using a limited type system. Because, okay, here's the other problem with type systems, is that they are yet another or multiple dimensions of design that you have to do. So an untyped language just has to worry about values and the runtime semantics, right? Now you're adding a type system. You're like, well, what types are provided? What types are available? How do I express new types? Can I do higher kinded types? Do I have polymorphism? Like, all this stuff just explodes the design space. And so writing a designing a good language with all those features becomes kind of hard. And I mean, kind of hard. It's much harder than not having them. And Haskell, people working on Haskell are like, they're committed to it and they're doing a good job at it. I think that a lot of the stuff is really well designed. But you can do something like Elm did and just have a much more limited type system and take inspiration from Haskell, but like find a spot that is much easier to design for the specific case that you're dealing with. Okay. What do I think about Rust macros? I don't know anything about Rust macros. What is this job interview? This was for a senior software engineer job. Okay. What else? Emmanuel, you're welcome. I hope you learn Clojure. I hope you can learn some more. I hope I get to help you more. Side-by-side edit preview in a lightweight DSL. It's a nice workflow, best of both worlds. Not just web front end, but also diagram. Okay. I don't know that. Elixir is adding static type checking based on set operations. It seems better than nominal type systems to model composition of information maps. What do you think about it? I guess again, it depends on the job you're doing, and in Elixir, like Erlang that it's based on, a lot of it is just maps of information. The challenge is to find a type system, because Hindley Milner isn't the only one. Like, talking about not liking the rhetoric. Part of what I disliked was people saying like, "Oh, you need a type system," or like, "Oh, that should be caught by the type system." Like, yeah, but what type system? There's so many to choose from. It's another choice I have to make, and maybe there's not even a practical language to use with that type system. So like, whenever I would complain like, "Oh, Haskell doesn't do this, I wish it did," someone would say, "Oh, what you really want is this." Like, yeah, but I can't do that in Haskell. So like, I'm not complaining about type systems, I'm complaining about Haskell. Okay, yeah. So I think that it's sort of like what TypeScript did, where they came up with a useful, pragmatic compromise between JavaScript's dynamic nature and what they could reasonably build a reasoner about. Like, that is what you want. That is my contention. Like, you want to let people write JavaScript, but also let the computer in some way help find problems in that JavaScript. And so if they have that, right? So they're not just doing types just to say they did types. If it's actually solving problems, like it's actually uncovering, inconsistencies, or like, hey, you thought this key was in the map, but it wasn't, and it's actually because of this other code over here. Like, that kind of stuff can be useful. And I hope that that's what Elixir is doing. So I can't comment on like, oh, is set theoretic types the right thing for Elixir? I don't know. I just know that what I would want to see is a list of problems that they expect to solve with the type system, and show how the type system that they have designed actually solves those. What advice would you give someone learning Clojure from a strongly typed language like Scala? So you're going to have a big advantage because you're going to understand types. What you're going to have to do, though, is use your own internal sense of the types. People who write dynamic programs do think in types. They do think, oh, this takes an integer and a function, right? Or this function returns a list. They do think in those terms. They just don't write it down, and it's not checked by the compiler. So the big struggle you're gonna have is, I hear this a lot, like, well, how do I know someone isn't passing the wrong thing? And the answer is you don't. Just pass in the right thing. Keep it in your head. We use in Clojure, we often use the names of the arguments to indicate their types, and so that's good. The other thing is, if you find yourself getting lost in the types, so you're like, oh, this map, what keys does it have, and what if I go to this key and then it has a submap, and I go to that key and it has another submap? How I can't remember, I can't keep track of it in my head. If you can't keep track of it in your head, the code is too complicated. That's my other advice. So keep track of it in your head, and if you can't, simplify it. Okay, here we go with the last question, and then I'm gonna get off the stream. Given LLMs, what do you make of the mapping of natural language expressions of domain aspects into types, operations, etc. in formal language, iteratively in a back and forth manner? I mean, this is probably the best use of it, I think. People, and I want to try this now that you mention it. People talk about like giving the LLM some coding task, like, hey, build me a web server that does XYZ. And that's cool. Like, if it can do it, that's great. But I think the real advantage is something like what you're saying, where somehow you can iterate with it and ask for, like, can you give me, here's a type signature for this function. Ask it just like, what do you think it does? Right? And what would you name this? What if I said it was supposed to it was called this? What would you guess it did? And just iteratively refine it as sort of like as a sounding board. That sounds like it could be cool. I'm not so keen on using it to refine domain concepts. I don't know why. I just feel like it has something to do with like the fact that LLMs just kind of give the average answer. And I feel like the average answer is not what you're looking for. You want something highly specific to your task. So, but it's worth experimenting with. Like, how could you, like you could say, hey, I have this problem. I need to model a coffee. Can you give me like a data model for the coffee? And then it gives you something, and you're like, no, like what I mean is there's 3 kinds of roasts and 3 sizes, and they're called this. Okay, now show me what that model would look like. Yeah, it might be able to find something. It might. It's worth experimenting with. That this idea of like you being able to be kind of informal and just use English, and it guessing at what kind of formal expression that would look like. That's actually kind of cool. I want to try it. Okay, thank you everyone. I love the questions. Thank you to the 2 people who were generous enough to share their questions on screen, and thanks for the people in the chat. Love the questions. I'm over time, but I'm happy to do it. This was a ton of fun, and I hope to do it next week as well. So please have questions and things available, and you can jump in the Zoom. All right. Thank you so much. Bye.